exams like the 8 pages that we printed out, I think I'll be okay. I've got a couple things that I think we'll have good conversation. If it's way off base from this, I'm going to be in trouble.
Yeah. Honestly, I haven't been able to look at it a whole lot this week. It's been kind of a crazy week so far, but
yes, we have 32 different questions to go through tonight.
Right. Carrie, did you get through that review at all?
I did not. Yeah, sorry. I drove early unprepared tonight.
Okay.
It's just general. It's a review of the 7 past lessons and to apply pretty much everything what we have learned so far. Okay, so whenever you're ready, we can start.
Okay, I'm ready whenever.
Okay, let's do it.
Okay, so then it says section 3, review questions. First one says, what is the name of the important statistical result that guarantees that the sampling distribution of sample mean will be normal if the sample size is large?
That was the central limit theorem, is that right?
Mm-hmm. That's the one that I came up with. Okay. Number 2 says, what is the name of the important statistical result that states that when the sample size is large, the sample mean will be close to the population mean? Came up with law of large numbers.
That's what I found as well.
Okay. So anyone wants to read number 3?
3, which of the following variables are categorical? Number of animals in a local zoo, a randomly selected brand of toothpaste at a convenience store, or age in years of randomly selected vehicle in a parking lot. Categorical, that'd be 2. The second one, right? Randomly selected brand.
Correct. Yes. Yes. The second one will be the one which is categorical.
Correct. Okay. So number 4, the mean IQ test score in the United States is 100. 20 randomly selected statistics students took an IQ test, and the mean of their score was 112. Which of the 2 numbers is a parameter and which is a statistic? And this one I had to go back and review, but my understanding was that parameter is described as largely unknown, and the statistic is a sample of the unknown. So the parameter, they're giving us a mean of 100, and I put statistic 112. That's what my choice was and why I thought that way.
That sounds right.
Mine as well. Okay, number 5 says Rhythm City has 4 distinct neighborhoods. The property values are very similar within each neighborhood, but they vary considerably from neighborhood to neighborhood. One neighborhood has very low property values and another has extremely high property values. Property taxes are usually roughly proportional to the property values. What type of samples should we collect to gauge the residents' responses to a proposed increase in property taxes? I came up with a cluster sample since this has been divided in 2 different blocks.
That sounds right. Yeah.
See, and I thought that it should be stratified, but I struggled with this one to make sure, because cluster tended to be all of the unit. In this one, it seems like they're separated into similar groups. You've got different neighborhoods, that are all going to be within a similar range. And then if you took a random sample of each neighborhood, you would get a true sampling of what the entire group was. That was, and I don't know if that's the right answer, but that's the way my brain thought about this one.
That's a
No,
good.
I think you are
Yes,
right.
I was
think
thinking of that
stratified.
one. But since that specifically it's not mentioning that we can get just random samples, but it's just mentioning that we have the neighborhood with a extremely high value and another one which has the property values being low. I was taking it for segments having two blocks, but I don't know what you considered.
Well, the next one down is a good example of a cluster definition where they chose one and they used all of the students and they give you the information. In question 5, the reason I chose stratified is because they were asking us to determine which one would be best.
Okay.
To get that's, I mean, like I said, I'm not trying to, I'm just arguing why I made that point. I'm not saying I'm right. I'm trying to explain why I chose that. And I struggled with this one a lot.
Me too. Okay. So then we can take number.
Go ahead. The other question is would it truly be just a pure random sample?
Yeah, because it says when design experiments are conducted in public school systems, researchers typically choose a particular district and randomly select teachers of, say, 4th grade students in that district. The experiment is then conducted using all the students in the selected classes.
Right.
Which type of sampling scheme is implemented?
That's a cluster.
Yeah, that one sounds like a cluster. Yeah, I think you're right on the one before. I think it is stratified sounds more correct with me for number 5 and then cluster on 6.
Okay. Now moving on with number 7. Who wants to read?
7. At a school fundraiser, the name of every person who attended was entered into a drawing. At the end of the evening, 6 names were selected to receive door prizes. Which type of sampling scheme was implemented? That one's a simple random sample.
Yes, that's what I chose.
That's what I chose as well. 8, a special interest group is conducting a survey regarding wolves in Yellowstone National Park to adequately gauge the opinions on both sides of the political spectrum. The researchers took the list of registered Democrats and selected a simple random sample of 100 people. Then they took the list of registered Republicans and selected a simple random sample of 100 people. Which type of sampling scheme is implemented? Stratified.
Yes.
Stratified, yep.
Okay, so then says, go ahead.
The question that I have there is, so if you look at it and the pattern has been that they've identified all 4, would a systematic sample of those neighborhoods going back up to the top, would that be a better way, to have just pick a house, the 12th house in the neighborhood and then go? Or do you think that it fits stratified better than that first one that we talked about? Just really still has me messed up.
Yes, that is why I was thinking that was a cluster example, but now that if you explain it that way, for me it makes more sense being stratified.
Okay, then we'll just leave it at that and be happy.
Okay. Then it says, moving on, a survey was taken of purchases at a crossroads, open the data file, and then use this data to answer questions 9 and 10. And number 9 says calculate. Go ahead.
Before we go any further, was this asking for all of the data, or did they want it broke down by credit card, by cash, and by iCard? Because I did it all collectively, but then later I thought, as I read the question, I don't know if it means to break it down individually by group?
No, I use all of the data.
Okay. Okay.
Yes, because if not, it was going to be kind of tricky to divide all of those amounts and all of that. And yes, I just
Right.
used as it is.
Okay.
So then it says, number 9, calculate a descriptive statistics of the amount spent in Crossroads purchases. Give the mean, standard deviation, and 5-number summary of the data. That one, I have, that's number 9. For me, the mean was 4.771.
Yep.
The standard deviation, 1.912.
That's what I found.
And then the 5-number summary, the first one was 0.84, and then 3.395, the median 5.15, and then 5.71, and the maximum 10.45.
So my calculations from the spreadsheet showed 0.84, 3.42, 5.15, 5.61, and 10.45.
Yeah, mine are the same as yours. So the Q1 and the Q3 were different with Kevin's.
Mm-hmm. Yes, maybe because I was not using all of the decimal places with this ones. That was maybe varying a little bit.
Okay. And then for creating a histogram, I just used the spreadsheet and kind of did a freehand drawing on my paper here.
Yeah.
Yes, I use as well the spreadsheet to do so.
Okay. Okay, so the next section talks about Jessica Muir and her research team measuring body temperature sample of diving elephant seals. The thermistor was placed in a specific location on each seal to measure its body temperature. Body temperature of the seals tend to decrease as they dive. The researchers estimated the typical body temperature of each seal at the time they initiated dive and called this the representative temperature of the seal. Thermistors were placed in the hepatic sinus of 4 of the seals, and it lists their names, and it says the seal's body temperature at the start of the dive was calculated to be, and it gives you the list of each one of them: 37.91, 37.25, 39.86, and 38.116. Complete the following table and answer questions 11 through 14 below. So if I remember correctly, you need to find the mean of all of them. So add the 4 together and divide them by 4, and I came up with 38.075.
Yes, that's what I got.
I guess you could round it up to 38.08, but I left it as 0.075.
I prefer to leave it that way, 3 decimal places.
And
You
then
said 38.075, right?
38.075, yes.
Okay, yep, that's what I got.
Okay, and then to fill out the chart in the first column, you take the observation of 37.91 and subtract 38.075 to each one, and I ended up with negative 0.165, negative 0.825, 0.905, 0.085, and then if you square that for each one of them to get your next column over for the squared deviation, 0.0272, 0.681, 0.819, and 0.007225.
Well, with that one, I got a little bit different.
Okay.
Just what I want to make sure is that on the second column, the deviation from the mean, you were taking first 38.075, or were you taking first the sample of 37.91, let's say?
Sample, it should have been sample minus mean.
Mm-hmm.
37.91 minus 38.075.
Mm-hmm. Yes.
0.165.
Yes. No. Yes. Yes. I just wanted to make sure.
Okay.
Mhm.
So then it says, what is the value of the number that goes in position A marked? And I put negative 0.165.
Mm-hmm. Correct.
And B was 0.681.
Yes.
And then it says, what quantity is equal to the sum of the numbers in the squared deviation column?
Just add those up.
Asks for, it gives you four different options there. So the squared deviations is not the mean, it's not the standard deviation, and it's not the variance. It's your, what do they call it?
Yeah, what do they call that?
Sum of squares, right? Is what they call it in the book.
If not mistaken, it was not that one the Z option, letter C.
You thought it was the variance?
Hmm. If not mistaken, it was not the name of the. Just going from my notes, sample of variance. Was not that one. I thought it was that one.
That was the closest one, but whenever I went back and reviewed, all I could find was the sum of the squares.
Well, I got it here in my notes. It says variance, it's the square of the standard deviation.
Okay. Well, then I guess that's probably what it is.
So it is variance then?
Yes, variance.
Okay.
Okay, so then it says for number 14, what is the standard deviation of these temperatures? I got 0.715.
That's what I got as well.
Yeah,
Okay.
that sounds.
And number 15, it says true or false. Under certain conditions, the standard deviation can be negative. It will be false. Okay, so next one, number 16, it says in the same study, the researchers placed thermistors, temperature sensors in the three cells named Chick, Starburst, and Patty near their spinal cord and brain and the striatal vein. They placed thermistor in 6 other cells, the names, and then it says in their aorta, the largest artery in the body. Finally, they placed thermistors in 4 other cells in their hepatic sinus. The results from this study are summarized in the table below. It says which location resulted in the most consistent temperature measurements from one cell to another. Justify your answer.
Right? So I put
That's
extra because it was the smallest deviation from the mean.
yes, I selected that one as well. Extraterral.
Okay.
So number 17 says in your own words and without using any mathematical symbols or statistical jargon, explain what the standard deviation is. Do not tell how to calculate the standard deviation, but explain what it represents. I came up with my own words that it is a measure of the spread and the distribution.
Yeah.
Just simple.
Yep. Represents how far apart data is from the mean of a sample.
Mm-hmm.
Right.
Good enough as well. Okay, so who wants to read number 18?
give the 5-number summary of this data. So that would be the 2, the 4, the 6, the 8, and the 12.
Mm-hmm. Yes.
That's what I have as well. Yes.
Mm-hmm.
And then for the next one, where it says what percentage of the data lies between 4 hours and 8 hours, well, if Q1 is 25 percentile and Q3 is 75, that leaves 50% between the two.
Mm-hmm. Yes.
Okay. Continuing on, it says observation from normally distributed population is considered unusual if it's more than 2 standard deviations from the mean. There are several contaminants that can harm a city's water supply. Nitrate concentrations above 10 parts per million are considered a health risk for infants less than 6 months of age. The city of Rexburg reports that the nitrate concentration in the city's drinking water supply is between 1.59 and 2.52 parts per million. And values outside of this range are unusual. We will assume 1.59 parts per million is the value of the mean minus 2 standard deviation, and the mean plus 2 standard deviation is equal to 2.52 parts per million. It is reasonable to assume that measured nitrate contributions are normally distributed. Use this information to answer questions 20 through 22. So it said estimate the mean of the measured nitrate concentration in the drinking water there in Rexburg. So for this one here, I don't know if I did it correctly, but I basically took the 2.52 and subtracted 1.59, and I came up with 0.93. I divided that by 4 because there's 4 points that separate them. And I ended up with 0.2325 rounded to 0.233. And then I used that 0.233 to be each one of my standard deviations. So beginning at 1.59, I added the 0.233 to have the first standard deviation be 1.823, the mean to be 2.055. The first standard deviation going in the positive side was 2.2875, and the second standard deviation going is 2.52. So I don't know if my math is correct, but that's how I approached that. And if either one of you have a better way to do that, I'd be open for suggestions.
Well, with this one, I was kind of struggling to figure this out.
Oh yeah, I mean, for just the mean, I just took the 1.59 plus the 252 and then divided by 2, and that gave me the 2.055, which you had for the mean.
Mm-hmm.
But yeah, you got all that other information with what you did.
Yes, I just got as well as Carrie just the 2.05, but then all the explanation you gave us, I didn't figure it out that way.
You did or you did not?
I came up with the 2.05 as the mean,
right?
Just adding both of the margins that it's giving us.
That may have been a faster way to do it,
but just the way you explain it, for me it's fine as well. It's very descriptive.
Right. Okay. So the mean of 2.055, estimate the standard deviation of the measured nitrate concentrations. I put 0.233. And then between the two measured nitrate concentrations do approximately 68% of the data values lie. That would be the first standard deviations in each direction, 1.823 to 2.288. And then here's where I got confused or frustrated. Mm-hmm. What is the mean standard deviation of the standard normal distribution? I don't remember how to calculate that one.
What is the mean standard deviation of the standard distribution? Let me go to 23. Number 2. Just go back to this one. Yeah, it's just gonna go to my calculations in here. What is the mean and standard deviation of the standard normal distribution?
Because the mean is the same mean that we found, correct?
Yes.
And standard deviation is the standard deviation divided by the square root of n. Well, I don't know what n is.
Just go over this again. It says between what two measure network constructed decimals and where the values lie. What is the mean and standard deviation of the standard normal distribution? Yes, that's kind of complicated for me for this one.
Right.
It's asking us what is the mean and the standard deviation of the standard normal distribution. Let's take a look at this one. Just to read a definition, it says normal distributions do not necessarily have the same means and standard deviations. A normal distribution with a mean of 0, just let's say, and a standard deviation of 1 is called a standard normal distribution.
Okay.
Then it says RS of normal distribution. It says RS of the normal distribution are often represented by tables of the standard normal distribution. A portion of the table of the standard normal distribution is shown in, and it's just showing me a table.
So it's not tied back into the questions we did. It wanted to know what the mean and standard distribution. So it's 0 and 1. A normal distribution with a mean of 0 and a standard deviation is one called a standard normal distribution. So I believe that's mean of 0, standard deviation is 1. Okay. Makes sense. Instead of trying to force it into something that it's not, just accept the answer that's written down in front of you, I guess, when it comes out of the reading.
Yes. Okay. So do you want to move on, or any other question so far?
So for the next one, the whole next section, I had to remember that the Z formula is the observation minus the mean divided by the standard deviation, unless you're given a sample size of n, and then you have to do the square root of n.
Correct. Yes.
Okay.
So this is all calculations.
Okay, and so when you're doing probabilities, if it's asking what is the probability that you'll have a score that is greater than whatever, you want to enter that Z score and then shade to the right if it's greater and shade to the left if it's less than, if that's what the probability that they're asking for. Is that correct?
Yes.
That sounds right.
Okay. All right.
So this is pretty much what we did last week in lesson 7. So then, for example, it says the admissions committees for most Masters of Business Administration program require the graduate management admission test. As part of the application for new students, it has been shown that the scores in the GMAT are normally distributed with a mean of 542.3 and a standard deviation of 120.54. The minimum GMAT score required for admission to the MACC program and the School of Accountancy of BYU is 500, but it is rare for students with scores less than 600 to be admitted. Use this information to answer questions 24 through 32. And 24 says, what is the probability that a randomly selected student will score above 542.3 in the GMAT? And I came up with, and correct me please if I am wrong, I got 50%.
Correct. That's what I got. because your z-score ends up being 0. When you subtract the mean from the mean and they're the same number,
Mhm.
any division of 0 is 0. So 50%.
Yes. Okay. With 25, it says, what is the probability that a randomly selected student will score below 600 on the GMAT? I got 0.479.
That's not what I got.
What did you got?
I got 0.735.
Okay. If you want, we can.
Yep, I took 600,
Uh-huh.
subtracted the mean,
5.23.
divided that by 120.54
Mm-hmm.
for a z-score of 0.628.
542.3 equal divided by 120. Second 600 minus 542.3 equal divided by 120.54. How much did you say you got for the z-score?
0.628.
628. Let me read this again. 600 because I'm getting 4 point something. So 600 minus 5.
My fingers could have done something incorrect as well. So let me look it over again.
That's why I'm redoing this as well. So we got 600 minus 542.3. It's 57.7. Then divided by 120 and 0.54.
Okay.
It's giving me a z-score of 0.479.
So if I do this one more time, because I just got it the same way, I've got to be hitting a button wrong somewhere. 22.3 divide by 120 point. That time I came up with 0.4786. So that will definitely change.
So then this will take the z-score for 0.479, and then the probability, and it says the randomly selected students will score 600, or it's 25. It says, what is the probability that a randomly selected student will score below 600? So it will be 0.6840. Type it on the applet.
Yep, that's what I get as well. 0.684. Okay.
Okay. Now, number 26, it says, what is the probability that a randomly selected student will score 600 or above? Will be just to subtract from 1 the answer we got in the previous one. And it will be 0.316.
Correct.
Yep. Yeah, that's what I had.
Okay. Number 27, it says, find the GMAT score that corresponds to the 10th percentile. With this one, what I just did, I just put 10% on the applet, and then I took that z-score, and then to solve for x. Is that what you did?
That is what I did.
So then I got 387.768. Is that what you got as the 10 percentile?
What did you have again?
387.768.
That is what I found. That's what my answer was for X when I did the math. Yes.
Okay. So then 28, it says find the GMAT score that corresponds to the 90th percentile. and I got 696.83.
Correct. That's what I got.
Okay. Is it what you got, Carrie?
Carrie, are you following along with that?
I'm trying to keep up, but yeah, I haven't worked it out, but I understand what you're
You
saying.
understand the process on that one?
Yeah, I do.
Mm-hmm. Yes, because with this one, what we need to do is just to use the applet to get the z-score, then to solve for x, which is the variable we are looking for.
Right.
So then, number 29, it says find the first quartile for the distribution of GMAT scores. So then it's 25%, if not mistaken, right? It's the 25%. And then I did the same, and I came up with 461.056.
461.056.
Mm-hmm. Yes.
Okay.
So to do that one, I'm trying to think, looking at it here, I'm trying to figure out how I did that. Once again, I came up with a z-score of 0.674, but did I do that by doing 25%? That we
Yeah,
did?
when I put the 25% in the applet,
Correct.
0.67, what comes up?
Mm-hmm. Yes. And because it's only 25%, it's the negative 0.674.
Okay, I just want to make sure that we were still that for my brain to just keep comprehending that we're doing this process.
Mm-hmm. Yes, for that one, I just type in 25 in the applet, and because it's asking just for the first quartile, I just took the negative 0.674 equal to x minus the mean, which is 542.3 divided by 120.54. And then I solve for x.
Okay. Yep.
Okay. Number 30, it says find the third quartile of the distribution of GMAT scores. This is the same way, just using 75%.
Yep, so use a positive 674 on this.
Yes. Yes. Using the positive one because it's on the other side more than the mean. So this one, it's 563.277 is that I came up with.
Correct. That's what I did.
But then I just read the part before, and then it says consider a simple random sample of n equal to 15. And then I using the square root of 15, and I came up with 563.277.
For which one?
Number 30, was not that one the one that we needed to use the 15, or was just for 31?
For 31. So far, the pattern has been they give you instruction, and then you answer the next question with that information. So I took that to be considering a sample random of 15 students taking the GMAT. What's the mean and standard deviation of the distribution of sample mean scores for all such samples? So the mean is going to be equal to the 542.3, and your standard deviation of all of those is going to be the 120.54 divided by the square root of 15. I got 31.132 for the standard deviation of all of those.
Yes. Okay, I just wanted to clarify that one. So then the sample of 15 was just for question 31 and not for question 30.
That's
right.
The way I read it.
Right.
Okay. Okay, just wanted to make sure.
Okay.
Okay, so then number 32, it says, what is the probability that the sample mean GMAT scores for ASRS of n equal to 15 students will be greater than 600? And I came up with 0.514.
I came up with 0.0319. The reason I got that was, so we're looking for greater than 600 with a random sample of 15 students.
15.
So the 600 minus the mean divided by 120.54, which was then divided by the square root of 15.
Square root of
Correct.
15, yeah.
And how much did you get for the z-score?
Z-score I got there was 1.8539. Let me do my math because
I came up with 0.036.
let me try this one more time because
Let's redo this one. In 3, it's 57 again, 57.7. Then divided by square root of 15. 120, 54 divided by that. That's 31. And it says 57.7 divided by that amount. And you said you come up with 1.853?
1.8539, 1.854.
Yes, that's what I got now. Yes, sorry.
I got 1.83. Did I do it?
If we round it, it will be 1.854. Yes, you're right, Sean. So then, if I type in the example in here, 1.854.
Yeah, 1.854.
This will be greater than.
So if you shake to the right of that.
So you come out with 0.0319?
Yes.
Yes, that's the right answer.
0.0319, you said, right?
Yes.
Okay, perfect.
So would you like to go ahead and go over any of these 32 questions, or just to move on with the quiz? Or if there is another question?
I think I'm ready for the quiz. I mean, we can talk through it as we go if we need to.
Okay, so let's move on to the quiz. Let me pull that one up. This. Okay, for number 1, it's just true.
Okay, start quiz.
So I think the quiz is just for the question 2. It says the number of animals. The number 3. I think it's just what we solved already.
So is the crossroad, is that going to be?
So then for the first one, the cat will be the second option. The random will select a brand of toothpaste at a convenience.
Pull it up.
Okay.
One of the things that Professor Bennett said, or Brother Bennett said in one of the class recordings that I listened to was always use the most current. I don't know if that's something I really, if there's going to be any difference or not, but I don't think it hurts for me to reopen this and make the right data here.
Okay. You won't let the following data.
Okay. Oh, wow. I didn't realize we're supposed to take the quiz before meeting with the group and then again with you guys. Okay.
No, me either. I just read that as well. Okay. So then.
So that.
Gary?
What was that, sorry?
Okay. So then for question 2, we mentioned the categorical one is only the second option. You randomly select a brand of toothpaste at a convenience store.
Right.
Question 3, we deduct that 100 was the parameter and 112 was the statistic.
Yep.
And number 4.
Hold on a second here. So
Mhm.
100 is the parameter, 12 is the statistic.
Yeah, so we can select both of those on that one, right?
Mm-hmm.
So I guess let me just real quick, are we supposed to be taking this? Did I miss that in the syllabus somewhere that we're supposed to take the quiz before we get together?
I didn't notice that either.
No, me either.
Okay, well, I guess if that's what we need to do, then I'll be happy to start complying. I just haven't got that far yet. So,
yeah,
all right.
I would imagine we're okay to go through it. I mean, since we've already gone through it together.
Right. Okay. So continuing on. Sorry to interrupt. Thank you.
That's fine. For number 4, so then we concluded it will be a stratified sample, correct?
That's what we came up with.
I guess we'll find out. But that's what I think. That's what I believe.
Okay. Number 5, we came up that it was. Have my notes in here. Understand experiments coming. Yeah, it's a cluster one. Cluster sample. Then number 6. Number 6, it was at a school fundraiser. The name of every person who attended was entered into a draw, and at the end of the evening, 6 names were selected to receive the door. It was a random sample. Mm-hmm. So then number 7. Special interest group, it's conducting a survey and it recorded wolves in a Yellowstone. So this one we concluded this all was a stratified one, correct?
Correct.
Last one. Mm-hmm. So then it says number 8, a survey was taken of purchases using software to calculate the mean of the amount spent. So do you want to use the most updated one, the one we just?
We just plug that in.
That's the one we did in the assignment, right?
Yep.
I still have that. The mean. I believe it was 4.771.
Let me check it here. 4.771, yes.
And it did not change, so that is correct.
Okay.
Okay. So then moving on with number 9. That's using software to calculate the standard deviation. So the standard deviation was 1.912.
Yep. 912.
Number 10 is false. Oh, sorry. I created histogram representative. Yes, this one is true. I thought it was the other one. This one is true. I did a histogram. I thought it was the other one, which was true or false. Then it says the information about the temperatures. It says complete the following table and use your work to answer the next questions. So number 11, it's asking us what is the place for letter A on the on the table. And it was the 37.91 minus the 38.075. That's the negative 0.165. Do we need to
Correct.
place the minus sign in here, correct?
Yes.
0.
So it is a negative 0.165.
And it says number 12. What is the value of the number that goes to the position marked with and B on the table above? This one is the 37.25 minus 38.075 to this power. To this one, I have 0.680.
Would it be 681? Because I got 0.6806.
Yes. That's rounding it, yes.
0.681.
Are you okay with this one, Sean? Number 12?
What's that?
Yes.
Just
0.68.
Right.
Yes.
That's what I got.
So then what quantity is equal to the sum of the numbers of the square deviation? Is the variance?
That one. Variance.
See, the only thing is, I thought that the variance, you use the sum of the squares to find the variance. Because wasn't there a variance formula that it was the sum of squares divided by n minus 1 to find your variance?
Yes, that's the formula. Sum divided by n minus 1.
So I still don't think that column is represented there in the square deviations. I think that's called the sum of squares, which isn't an option here. And you use that number divided by n minus 1 to get the variance.
Yes, because what the question is, what quantity is equal to the sum of the numbers in the square deviations column? So the square of the standard deviation. So then, yes, it's the sample variance. So then you think it's none of, because yes, it's not mentioned in here because it's not centered, it's not the mean.
That's what I think. I could very well be wrong. I'm just.
And because of how many notes from the reading, it says just the variance is the square of the standard deviation. But it's not specifically, as the question is asking, the sum of the numbers of the square deviations column.
Right.
Yeah.
So then we can go with because none of these is correct.
That's what I think.
Okay, so then let's go with that one because yes, it makes sense because the question is what is the equal to the sum of the numbers, and the variance is the square for the standard deviation, but not the sum of all square deviations.
Right.
Yeah.
That's. I don't think it's either one of these. That's my answer.
Okay. So the number 14 says what is. And it says, what is the standard deviation of these temperatures? That's number 14. Let me get answers. Number 14. Come up with a 0.715.
That's what I have as well.
0.715.
So then this one is false. because standard deviation cannot be negative.
False. Or, yeah,
It
false.
says
Okay.
number 16, which location resulted, we concluded was the extraditol, correct?
Correct.
Yep.
So the number 17, what is the third quartile? That's 8.
8.
So then what percentage of 3 is between? Note least the number is a percent and not as a decimal, and don't include the percent sign. So it will be 50. Just the number 50.
Yeah, it should be 50.
Then it says for number 19, estimate the mean of the measured nitrate concentration in Rexburg. So we came up with 2.055, correct?
Yes.
Then it says number 20, estimated the standard deviation of measured nitrate concentration. This is number 20. How much did you get for this one, Ashan, for the number 20, the standard deviation for this one?
0.233.
0.233, okay. 233. Then it says between what two measured nitrate concentrations to approximately 68% of data values lie in. This one was within 1.823 and 2.288.
That's correct.
Then next one says, what is the probability that a randomly selected student will score above 542.3? That's the 50%.
Right.
So do we write it at 50 or 0.50? What do you think? I didn't see the instructions for this one.
This one doesn't say. I would think 0.5.
That's what I'm putting in there.
0.5. This is number 23. What is the probability that a random student will score above? That one it's 0.684, correct?
Sorry,
This
what was
one
that?
score below 600, and that's shade left of that 0.684.
684. And then above, it will be 0.316.
Correct.
Round to the nearest whole number. It's number 25 to 10th percentile. This one it will be 388 then.
Correct.
388. Then number 26 to the 90th percentile to the nearest whole number will be 697, correct? 697.
I got.
Then number 27, that's the first quartile. That one will be, for this one, it's the whole number 461.
451.
And for the third quartile, to the nearest whole number will be 563. 163.
Are you sure about that one?
About this one?
The third quartile.
28. Let me go to my notes again. It will be having a z-score of 1.282 multiplied by 120.54. That's 154.53228. And then we will be adding 542.3. It's given me 6. Yeah, sorry, you're right. It's 696.83. Yes, 697.
I'm a little confused on this one. I've got 605. I thought we worked
605. Okay, if you want, we can read this again. If we're typing on the applet, the 75 percentile, this one will give us a total of
0.75, right?
I'm sorry?
Yep, 0.75, correct?
If I type in 75 right now, it's given me.
So in the area, you want to type in 0.75, correct?
Yes, yes,
And you want everything that's shaded to the left of it, correct?
yes. And this one, it's given me, yes, a z-score difference, 0.674.
Correct.
So then you must be right with this one. Let's try it this way. 674 multiplied 120, 54. That's 81.24 plus 542.3.
524.3.
524.
Is that where that's where I messed up? Okay, that's where my math is wrong. See, I'm glad you guys are here to keep me straight.
No worries. 674 times 120.54 plus 542.3. I'm coming out with 623.54. Is that what you're getting?
2.3 equals 120. Nope, I hit my 20.54. Equals 623.66.
So it'll be 624.
624 is what I got.
Now, going back just to make sure, with the one which is asking the first quartile, you're getting as well 461, or do you want to just
No, I had
go over
461.
461?
I didn't. I had the right number written down for that one, and I had the wrong one written down for the next. So.
Okay, it's 624. Then for number 29, it says consider a random sample of n equal 15 students taking GMAT. What is the mean of the distribution of sample mean scores for all such samples? Round to the nearest tenth will be 542.3, right?
Yes.
6.3. Yep, that's what I got.
Then it's asking for the standard deviation. So then that one will be having a sample of 15. This one 120.54 divided by that one. Standard deviation, and it's rounded to 3 decimal places, 31.123.
That's what I have.
Then last one but not least says, what is the probability that the sample mean GMAT score will be greater than 600? be 15. This one. 54 divided by this one. Third division, then 600 minus 452.3 divided by. Then what is the probability? Tap it on the applet. So I'm getting for the z-score 1.854.
Correct.
This one greater than that one will be only 0.0319. We're going to round it to 3, 0.032. Because we need to round it to 3 decimal places.
Correct.
Mm-hmm.
Good catch.
So then let's go ahead and check how it goes. Just like the charger. Right. So as for number 4, the best one was the stratified one. Thank you, Sean.
Yeah, good job.
Good go.
So then for the rest of them,
Nice.
we got them all.
Nice.
Good.
Such an amazing team.
All right.
Yeah.
Fantastic.
Yeah. Sorry I wasn't more prepared, guys. I appreciate you letting me kind of tag along with you guys. It's been a rough week, but next time I will definitely be more prepared.
You worked through it good.
No worries, point.
Carrie, where are you off to on Thursday? You're going to be here?
Yeah, it's a daddy-daughter dance at my daughter's school.
Okay.
So it goes from 6 to 8 our time, and so I should be home by 9 or this time, so which is an hour later than.
Okay. So I'll be sending the link if it's fine with you all 1 hour later.
That's fine with me.
All right, I appreciate that again too. Thank you.
Okay, so thank you so much for your help today. I understood better the topics now. Thank you.
Very good, gentlemen. Have a good night.
Okay, have a good one then.